This week at NASA.
I'd like to introduce to you today the bacterium GFAJ-1.
A team of NASA-funded researchers has discovered a bacterium that can live and grow without phosphate salt, an essential building block for life as we know it. The bacterium from the toxic and briny Mono Lake in California was also shown to sustain itself and grow on the toxic chemical arsenic. This is the first microorganism known to thrive this way and will change how scientists search for life in space.
I've led a team that has discovered a microbe that can substitute arsenic for phosphorus in its major biomolecules. But let me step back for a minute. All life that we know of requires carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And it uses those 6 elements in some of the critical pieces I think we're all familiar with, including DNA and RNA, or the information technology of the cell, the proteins, which are the molecular machines, and the lipids, which separates you from everything else. And so we've discovered an organism that can substitute one element for another in these major biomolecules.
With respect to space exploration, this is a very interesting result again, because the implication is that we still don't know everything there is to know about what might make a habitable environment on another planet or a satellite of another planet. We have to increasingly broaden our perspective. So perhaps arsenic is not an essential component for habitability or for life, but it may be one that can be tolerated.
Until now, astronomers and scientists have believed that without phosphates, life couldn't exist anywhere else in the universe. Discovery of this arsenic-eating bacterium tells scientists they need to re-examine how and where they look.
There's really no way we can get there before the December launch window. So what we'd like to do now is just kind of take that off the table, let John and his team do a little bit of planning over the next several days, first part of next week, and analyze the overall test plan and the workflow between now as we go forward. So we're kind of setting the next launch date just tentatively around February 3rd.
After reviewing the progress of repairs that have delayed Discovery's launch, shuttle managers determined that more tests and analyses are needed before proceeding with the STS-133 mission to the International Space Station.
We've hit a point where there is no obvious answer as to what occurred. What that means is that we have to take the next step, and we have to look in greater detail to understand what types of stresses you could put in these stringers during the assembly process, see how they could line up and add stress to that stringer. And we have to do that through a demonstration. Analysis is not going to get us there.
At issue, cracks on 2 20-foot-long U-shaped aluminum brackets called stringers on the shuttle's external tank. The cracks have been fixed and the stringers recovered with foam. If Discovery proves ready to go on February 3rd, liftoff from the Kennedy Space Center would come at 1:34 a.m. Eastern.
These tests stand to really move us forward. We're at that point in the troubleshooting where we need to go add these additional tests. We'll take the time to do that, and we'll get ready to go fly when it's time to go fly.
We just finished a very successful first science flight on Sophia. Almost 10 hours in the air. We flew out over the ocean, and we spent a large part of the flight on one of the most famous infrared sources in the sky, the star formation, the Orion Nebula, in the constellation Orion, plus several other objects. And in general, things went very well.
NASA's Stratospheric Observatory for Infrared Astronomy